Chapter 37, Problem 2 reads, the positive muon, which is an unstable particle, lives on an average of 2.2 times 10 to the negative 6 seconds, measured in its own frame of reference before decaying. So A, if a particle is moving with respect to the laboratory with a speed of 0.9 times the speed of light, what is the average lifetime measured in the laboratory? So to do this is pretty simple. We use our time dilation equation, t equals t naught over the square root of 1 minus u squared over c squared, c being the speed of light, t naught being the time the particle lasts in its own frame of reference, t being the laboratory's frame of reference, c being speed of light. Plug those into the equation, so time of the lab's frame of reference is equal to 2.2 times 10 to the negative 6, which is the muon's lifetime, divided by the square root of 1 minus 0.9 times the speed of light squared, because that's the velocity of the muon, divided by the speed of light squared. Your c squareds cancel out, plug into a calculator, and in the frame of reference of the lab, the muon lasts 5.05 times 10 to the negative 6 seconds. Part B says, what is the average distance measured in the laboratory, and does the particle move before decaying? So the average distance is just your average velocity times your time. Since we're doing the lab's frame of reference, we use the lab's frame of time observed. So that's just 0.9 c, c being 2.998 e to the 8th meters per second, velocity of our muon, times our answer from the previous, since that's the time the lab observes. Plug that into a calculator, and the lab sees the muon travel 1,361.8 meters.